Then the topic for today is solve systems by graphing. Okay. Then in the first example, example 1, we need to solve a system by graphing. Solve a system by graphing. And we can read the problem, what they are asking us in the problem. Lee is choosing a new cell phone plan. How can Lee use the graph of a system of linear equations to determine when the phone plans cost the same? And which plan should Lee choose? Okay, we need to explain at the end what plan she needs to use. For the company A, we have the data, okay? We have the information that 1 minute is going to cost 20 cents plus $75. The $75 are for the unlimited data. For the company B, each minute is going to cost 25 cents and you are going to pay $70 for the unlimited data. So we can write the system of equations. In the step 1, you can see that they ask you to write the system. So in what way are we going to relate this? If we let x be the number of the minutes, remember that we don't know the number of minutes that this person is going to talk. So we use one variable to represent the number of minutes, in this case x. And y is going to be the total cost of the plan, okay? The total cost of the plan each month. If we write the system of equations like we have on the book, for the first one, y is equal 0.20. This is the cost for each minute. And you multiply it by the number of minutes. In this moment, we don't know the number of minutes, but we use the variable to represent this. 0.20x plus 75. The 75 is the cost for the unlimited data. In the other one, for the other company, y is equal 0.25x plus 70. That this is the cost for the unlimited data. So what we are going to do, we are going to graph these equations, both equations, and we are going to find if they are to intersect. They are going to intersect at some point or not. In the graph, you can see that actually they intersect at one point. So they have one common solution, but we are going to understand other things in the graph, okay? So I'm trying to do the graph with you. We have this part in here. This is for y, this is for x. How to write with you correctly the scales in the grid is difficult, okay? But I'm going to try only to show you the form of the equation, at least the form of the graph. So for example, the first one starts in here, something like this. And we have the other line. We have the other line that is like something like this. And they have a common point. They have one point where they both intersect. This is going to be our solution in this case. So what I'm going to write is the coordinates for the point, because remember, I don't know how to write correctly. I don't have the grid to show you each number. So I write the important things like this number that we are going to need it. Imagine that you graph everything and you find that the point where they both intersect is this one, 195 for y. So the green color is for the company A. This is for the company A, and you write the equation y equals 0.20x plus 75, and the black one is for the company B. And you write the coordinates, you write the equation that you graph. Y is equal 0.25x plus 70. But you need to understand the meaning for this intersection. What is going to represent this? That is one moment when this girl could talk 100 minutes and she is going to pay only $95, okay? Independent on the company. For both companies, in one moment, you can see the interpretation that you have below. If Lee uses 100 minutes each month, both plans would cost $95, okay? Remember that I'm writing for the number of months. So in this case, for example, in 1 month, she only talks 100 minutes. It's convenient for her because she is only going to pay $95 in both plans. Okay, the lines intersect. This is a little advertisement that we have on the graph. If the lines intersect, there is one solution. This is the solution you have. I already read it with you about the number of minutes. But they ask you more things about to interpret this graph. They give you the graph, so you need to interpret what is happening in here. Remember that for X is the number of minutes used. The number of minutes you use from the plan. And for the other one, this is the cost. This is the monthly cost. I'm just writing the cost because you already know that it's for each month. And how you know what company is going to be more cheaper or each one is going to cost more money each month? You see the graph. For example, you can see that the company B started in the y-intercept was little, okay? It was smaller than this one. But after she talks more than 100 minutes, the cost is going to increase. Remember that the y-axis is representing the cost. So if it's higher, higher is the price, okay? Higher is the cost that she is going to pay each month. So if Lee uses fewer than 100 minutes, she should choose the company B. You can see that when it's less than 100 minutes, this is on the bottom, okay? So it means that this company B is cheaper if she talks less than 100 minutes. But look, when we pass the 100 minutes, it's expensive. The graph is on the top of the other one. And it's the opposite with the company A. That's the reason why I write the names for the companies and for the equations. For the company A, we start a little expensive, but after the 100 minutes, it remains, okay? The value is still constant, so we have a cheaper value. It doesn't increase so much because it only costs 20 cents for each month. In this case, it's the opposite. It's 25 cents. So 5 cents each time for each 1 minute is going to increase more. Okay, it's going to increase faster than the other one. Okay. I'm going to write the y-intercepts for each one so you can see the difference. One need to start in 70. Look the y-intercept for this one. And the other one need to start in 75. So it doesn't look like, but it's a difference from 5 units. In here, there are 5 units of difference. It's a shame that I cannot show you exactly each one point because I don't have the grid, but this is what we have in here, okay? So you need to see where your graph starts. In this case, it starts the 70, this one, That's the reason why I tell you that this is cheaper. Before you talk 100 minutes, this is the cheapest one, but later it increases, okay? When you talk more than 100 minutes, you can see that increase, and it is on the top, okay? So this is the expensive one when you talk more than 100 minutes. That's the reason why they separate in two cases. When you talk less than 100 minutes, we should use the company B. But if this girl wants to talk more than 100 minutes, she should choose the company A, okay? Because when you talk more than 100 minutes, you can see that the company A is still in the, okay, it's the cheapest one. So then we can go to the example 2. In the example 2, we need to graph a system of equations with no solution. Okay, in this one, I was planning to use the other app, GeoGebra, but I'm going to do the graph in the same way like we have it in here, okay? I'm going to show you the graph and we interpret what is happening because this is the idea. Interpret what is happening, okay? So if I draw for the graph in here we have all the graph complete, so I'm going to do it for the, remember, y and x. I'm going to write it, y, and this is x. And now I'm going to draw the lines. The first one is something like this, but I'm going to change the color so you can see it. We have blue. We have something in blue. This one. And the other one is red. I'm going to write only the important values and the intercepts so you can see what's happening in here. Okay. This is what we have in the other one, right? You can see that they don't intersect at any point. Since this moment, I didn't write any number, but you can see that the graph are completely separated. They are not like this one, that they intersect in one point. They are completely separated. So I'm going to write the intersects, but you already know that this doesn't have any answer in common, okay? This is -4, and the other one is +4. These are the intercepts that appears on the book, what we have. Okay, so the system, what is the system for these equations? I'm going to write both equations in here. The first one is y equal, okay, x minus 4. And the other equation that we have is 2x minus 2y equal -2. Okay. This is the system of equations. Maybe I can write it in here so you can see it better, I think. Okay. You graph both equations and you realize they don't have any point in common. They are parallel lines. So do you have one solution for this one? No, right? And you don't have any problem like solve something. They only ask you to graph the system of equations with no solution. Again, why don't we have a solution? Because this solution is the point where they intercept. In this case, if they don't intercept at any point, so we don't have any possible solution. Okay, the lines are parallel. I already told you about that. I think that there's no much to explain in here because, okay, we don't have any solution. We don't have anything to explain about any exercise. And the last one is interesting too. In the last one, we have a solution in the example 3. Maybe I can write it for you that this is the example 2, so you remember when you study. This is the example 2, okay? And I'm going to create this space for the example 3 in here. Okay, For the example 3, we graph a system of equations, and in here we have more than one solution. We have infinitely many solutions. What is the system of equations they give you? The first equation is y equal 1/2 x plus 3. And for the other equation, we have negative 3x plus 6y equal 18. Again, we graph, but we need to, for example, you can see that this system of equations have two equations, but the first one starts with y. You are already isolated the variable y. But in the second one, you don't isolate the variable. You can see that you have negative 3x in here, and you have this multiplying the variable. So we need to isolate 4y in the second equation, okay? We need to find the value like in here, like the first one. So if we have negative 3x plus 6y equal 18. Okay, on the book they graph directly, but I'm going to show you why it's the same equation, okay? So negative 3x is subtracting, you pass it to the other side too. Add 6y equal 3x plus 18. And now the 6 is multiplying, so I pass it to the other side to divide. And you can say that y is equal 3 over 6x plus 18 over 6, right? You remember about this. So when you simplify, you obtain exactly the same first equation. Both equations are completely the same. 3 over 6 is 1/2, right? And 18 over 6 is 3. So can you see what equation we obtain? We obtain exactly the first one. So both equations for this system are the same. Y is equal 1/2 x plus 3. And the second one that I find the value is exactly the same slope and the same y-intercept. So what happened when we graph this? It's just one line. They are not two lines, okay? They are one. Or you can say that it's two lines, but one completely on the top of the other one, completely on the other one. So if we draw, in this case, the graph, we have something, okay? Something like this appears on your representation, okay? I'm going to use the green color like you have it. You have something like this. Imagine that this is the graph for the equation y equal 1/2 x. But this is the same like I have in here twice. So I only graph one time, only once, and it's going to be completely the same. Even if I graph again, you are going to have this completely on the other one. Can you see it? So one graph is going to touch the other one in all the points. They are going to touch in all the points. So we don't have only one solution. We have many points where they are touching, so we have many solutions. In this case, we have infinitely many solutions because we don't even can count how many solutions do we have. So the lines are the same, so the system has infinitely many solutions. Each point, x or y, on the line represents a solution. Each point that you can take from here can represent a solution. For example, on the grid, you can say one point that is 2 for x and 4 for y. It could be a solution. The other one that is 4 for x and 5 for y, it could be any other solution. Any point from here relating x and y could be a solution because they are touching in all the points. So this is about the number 3. there is infinite number of x and y pairs that make both equations true. So the system has infinitely many solutions. I think that this was the more interesting because we can think that maybe it's only one equation, but we have actually two equations, one completely on the other one. Okay. So I think that I can finish in here, guys. This part. Okay.